The Mayans, the Greeks, Aristarchus, Galileo, Newton. These are the key civilizations and figures that had a big influence on early astronomy. What did they do? What did they believe in? Let's find out now. Do you ever look up towards the night sky one clear night and think how long it would take to reach that star? That is, if it's still there. Since the beginning of time, astronomy, or the study of the universe and everything in it, has been the source of amazement and wonder for us. Astronomy is probably the oldest science out there, and even today, the universe is such a big mystery that questions are still being answered while new ones are arising. Take dark matter, for example. Recent studies have shown that dark holes have been ruled out as being the universe's dark matter. But we know that dark matter exists. We know that the visible matter that we can see in space, like the sun and stars, are being pulled by gravitational forces. But when we make our calculations, the visible matter doesn't add up to how fast they are actually moving. When you see something or someone on a theater stage magically floating in the air, you already know it's being pulled by a string. There's a string out there in space that's pulling objects the way we are. We just can't see it, and we don't know what it looks like yet. Pretty spooky, right? As the years go by, astronomers are making big strides and breakthroughs, with mysteries being solved and new discoveries being made all at the same time. But how did it all begin? Today on Feed My Curiosity, we present our new 3-part series on the evolution of astronomy. First up, Chapter 1, The Very Beginnings of Astronomy. Do you like what you're watching so far? Hit the like and subscribe button to stay up to date with us. The very first astronomical event took place some 13 to 20 billion years ago, the theorized Big Bang. In the simplest terms, the universe started off as a small speck before expanding into a big vast space full of stars, planets, meteors, and pretty much everything. The Big Bang theory is based off the framework of Albert Einstein's theory of relativity. Since humans gained intelligence and the ability to think, they have been constantly studying astronomy, trying to figure out to the best they could how the universe works. So what did our ancestors think about objects that existed in the sky? For one, we could look at our ancestors who lived during the Middle Paleolithic period. They studied astronomy together with their religious beliefs, specifically the priests. They thought of astronomical objects as holy and home of the divine gods. And the Mayans? They were one lost civilization who were probably the biggest astronomy enthusiasts. They thought that everything in the sky could be interpreted as paths towards their gods. So the moon, the stars, the visible planets, particularly Venus, and their movements were closely observed. The sun was known to them as Kanicheho, while the moon was a goddess named Ichel. They believed that the earth was the center of all these objects, and they had a significant influence on humans and the afterlife. They did not follow through with significant events until the objects in the night sky appeared a certain way. Their architecture and the way they were built were directly influenced by astronomy. Another way our ancestors studied astronomy is figuring out ways to track time and knowing things like which phase of the moon would be up in the night sky and when the sun would rise and set. So which civilizations tracked time, and how did they do it? In 32,500 BCE, people of the Upper Paleolithic period tracked the moon phases by carving the phase on animal bones. Around 2000 BCE, people of ancient Egypt and Mesopotamia used solar lunar calendars, the first people to do so. And in 45 BCE, the Roman Empire used a solar calendar known as the Julian calendar. There's the sundial. The earliest use of one seemed to be by the Egyptians, and the purpose of the sundial was to track time based on the length of the shadow created by the pillar in the center, known as Gimon. And how can we forget the Mayan calendar? They had their own way of tracking time too. The two calendars they used were the calendar round and the long count. The long count in particular may seem familiar to us because it was used as one of the predictors of Doomsday 2012, when a long count period was set to end on December 21st. In case you don't know yet, the world is still alive and well, and this has shown the influence of Mayan astronomy on today's world. So now that we've explored how our early ancestors studied astronomy, it's time to look forward a little and look at the pioneers who led the way and made advancements towards modern astronomy. Like the Mayans, early ancient Greeks, like the philosopher Aristotle, believed that the sun, the stars, and every astronomical body in the universe orbited around the Earth. This was known as the geocentric theory. This is where the ancient Greek scientist Aristarchus of Samos comes in. At around 280 BCE, he proposed that the Earth moves around the Sun and that the Sun and stars don't move in the sky. This was known as the heliocentric theory. Aristarchus also believed that the Earth spun on its own axis and takes a day to complete one rotation. The heliocentric theory was also supported by Nicholas Copernicus, who published a book titled On the Revolutions of the Heavenly Spheres, in which he said our solar system is indeed heliocentric and that the Earth and all other planets orbit the Sun. Then there's Hippocrates of Nicaea, another Greek astronomer. His biggest accomplishment was probably compiling the world's first ever star catalog in 129 BCE. Although the actual catalog wasn't preserved, it's still believed to be depicted in his statue on the globe that he's carrying on his back. There were also early observatories that were spawned back then. One is Persian Nasir al-Din al-Tusi's observatory, which was built in 1259, and is probably the earliest observatory to survive to date, preserved today with a metal dome. Another one is Ulugh Beg from the Timurid Empire in Persia, who had his own observatory built in 1420. It contained astronomical tables that cataloged over 1,000 stars. Perhaps the biggest invention for astronomy came at the time in 1608, when Hans Lippershey invented the telescope. Just look what took place afterwards. Italian polymath Galileo Galilei created his own telescope that could magnify images about 20 times better than earlier telescopes. He uses his telescope to discover the 4 moons of Jupiter. He also discovered that our own moon has craters, and that the Earth and our Sun is within a collection of stars that orbit around a supermassive black hole known as the Milky Way galaxy. Galileo was a strong supporter of the heliocentric theory. However, this got him into legal trouble because at the time, the Catholic Church were heavy supporters of the geocentric theory. Although Galileo was pretty much told to keep his mouth shut, he became increasingly convinced that the heliocentric theory was true over time. He was eventually found guilty of heresy and spent the rest of his life under house arrest before passing away due to illness. There were so many other breakthroughs that took place in the world of astronomy. One example is Johann Kepler, who came up with the 3 laws of planetary motion in the early 1600s. They state that 1. The planets move in elliptical orbits within the Sun at a focus. 2. In their orbits around the Sun, the planets sweep out equal areas in equal times. And 3. The squares of the times to complete one orbit are proportional to the cubes of the average distance of the Sun. In 1656, Christian Huygens discovers that Saturn has rings, as well as Titan, one of Saturn's moons. He also observes the markings on Mars, and 10 years later, Giovanni Cassini discovers that Mars has polar ice caps. In 1675, Ole Romer measured the speed of light, and in 1705, Edmund Halley correctly predicted the return of the comet, known as Halley's Comet. And who could forget Isaac Newton? He developed the theory of universal gravitation, while depending on Kepler's work. Newton also built the world's first reflecting telescope in 1668. By many, he is considered to be the founding father of modern astronomy as we know it. There are so many other discoveries made in ancient astronomy since then, which has paved the way for how we study astronomy today, which is what we'll look at in our next chapter on the evolution of astronomy. We looked at the very beginnings of astronomy and how we started studying the subject, from our ancestors living during the Middle Paleolithic period to the Mayans and the kind of influence they have had on how we study astronomy today. We looked at the accomplishments made by pioneers such as Aristarchus, Galileo Galilei, Johannes Kepler, and Isaac Newton. So what has happened with astronomy since? That's what we're going to talk about next with the second chapter, Modern Astronomy and Space Travel, right here on Feed My Curiosity. If you're enjoying what you're watching so far, hit the like and subscribe button to stay up to date with us. Perhaps the most important set of theories discovered in the 20th century was Albert Einstein's special and general theories of relativity. They have guided the way we understand and study theoretical physics in the universe. The theory of relativity basically explains that everything, with the exception of the speed of light, is relative to each other. Depending on our position as an observer, the way we observe something will always be different. The Earth is spinning at about 1,000 miles an hour, but because we're standing or sitting on this planet, we don't notice or feel it. But astronauts in space looking down on the planet would be able to see its rotation. Here's another example. Let's say you're sitting in your car and you wave at a friend as you drive by. In their perspective, they see you in the car speeding away into the horizon. But in your perspective, you see your friend moving away into the distance while the car you're sitting in doesn't move away from you. The theory of relativity also explains a variety of time dilation effects. The gravitational time dilation explains that the higher you are, the faster time passes by. Time is slower the closer you are to a massive object like Earth, because its gravity bends space and time. So those astronauts in space looking down at Earth, they would see time on Earth passing by more slowly. There's also a thing called relative velocity time dilation, which explains the faster you move, the slower time moves. Now don't take this information and think you can save time by speeding your way to work. Stay safe on the roads. Now we won't get into any more detail on how much weirder the theory of relativity gets, especially when you take into account what happens when gravitational time dilation and relative velocity time dilation happens at the same time. The point we just want to make is that the theory of relativity has had a big impact on our understanding of astronomy and how we study things in space. As the years go by, technology becomes more sophisticated, and we become more creative in how we study astronomy. As you can see, we are now at the point where we can study the universe firsthand. We're sending people into space, rovers on Mars, and we have big telescopes in space like the Hubble and soon-to-be James Webb Telescope to send us pictures of thousands of beautiful galaxies and nebulas. But how did we reach this point? How exactly did the age of rockets all begin? Let's rewind back a bit to the year of 1857, 11 years after Johann Galle discovered Neptune, 15 years after Christian Doppler discovered the Doppler effect, and 56 years after Giuseppe Piazzi discovered the first dwarf planet, Ceres. 1857 was also the year Russian rocket scientist Konstantin Tskovsky was born. He is one of the most important figures in astronomy because if it wasn't for him, we wouldn't have explored space with rockets the way we do today. During his early years, while he attempted to write science fiction, he wondered how humans would be able to go into space and make a living. And no such technology existed then. In 1883, he published an article about living in space. And in 1894, he published an article about an aerodynamically advanced metal aircraft. In 1903, he published a manuscript which was one of the most scientifically viable proposals to use rockets for humans to enter space. Tskovsky proposed using a fuel mix of liquid hydrogen and liquid oxygen, and years later, in 1926, Robert Goddard launched a rocket which used liquid fuel. He was able to conclude that it was more efficient than solid fuel. Tskovsky's rocket formula takes into account the changing mass of a rocket as it burns fuel, the velocity of the exhaust gases, and the rocket's totaling speed. This formula is believed to be the foundation of astronautics. In 1926, Tskovsky published a program which outlines the way humans can move into the universe. He proposed the use of rocket-powered airplanes, plants for life support, and solar radiation for food growth and energy. And in 1929, he published an article on multi-stage rockets. As a rocket's fuel was consumed, it would break away from the main rocket. Tskovsky passed away in 1935, but his legacy lived on. NASA's space shuttles, the first reusable spacecraft, uses multi-stage rockets to boost astronauts into space and uses the same fuel mix of liquid hydrogen and liquid oxygen that Tskovsky drew up. With all that research and dedication put into early rocket science studies, people today can study space up close in many imaginable ways possible. In 1957, the Russian Sputnik program launched the first ever artificial satellite to complete an orbit around the Earth. Within the same year, they launched a second Sputnik satellite, which the Russians used to study the biological effects on a dog. Meanwhile, the Americans, who were going at it with the Russians during the Cold War, stood up and said we can explore space too. Dwight D. Eisenhower's government made space exploration a priority, and in 1958, they launched the first ever American satellite to orbit Earth, which was called the Explorer. It was used to measure space temperature and micrometeorite impacts on the atmosphere. The Russian versus American space race didn't stop there. Yuri Gagarin entered space for the first time in human history in 1961. A year later, John Glenn became the first American to orbit Earth. In 1966, Russia's Lunar 9 and American Surveyor 1 successfully soft-landed on the Moon, and Lunar 9 transmitted the first lunar photographs back to Earth. Then, in 1969, the Apollo 11 mission featuring Commander Neil Armstrong, Command Module pilot Michael Collins, and Lunar Module pilot Edwin Buzz Aldrin successfully landed on the moon, something Robert Goddard always thought possible, and something John F. Kennedy wanted to accomplish since 1961. On the day of July 20th, Neil Armstrong spoke the words that would be echoed and quoted for many years to come. One small step for man, one giant leap for mankind. People grew more and more confident in launching rockets and satellites into space to conduct research and gather data, and they were going further each time. Russia and America were successfully sending probes and satellites to Mars, Venus, Mercury, Saturn, Jupiter, and Uranus. America's pioneer was even able to make it to the outskirts of the solar system, studying the solar wind and the incoming cosmic rays. People were also taking the initiative of setting up space stations. In 1971, the first space station was launched, Russia's Salyut 1. The first crew arrived shortly afterwards. It flew in low orbit for 175 days before intentionally crashing into the Pacific Ocean. And in 1984, Ronald Reagan gives the green light for the International Space Station. The ISS's first segment launched in 1998, and the first crew arrived late 2000. Then in the year 1990, the Hubble Space Telescope was launched into space by NASA's Discovery Shuttle. Since it became active, it gave us Earthlings some of the prettiest photos of the universe, like the Pillars of Creation and the Cat's Eye Nebula. It even gifted us with the Hubble Deep Fields, containing interesting-looking galaxies that are believed to have originated from the earlier days of the universe, 500 million years after the Big Bang. Space exploration didn't come without its challenges, however, including Apollo 1 in 1967, the Soyuz 11 in 1971, Challenger in 1986, and Columbia in 2003. Despite these tragedies, people were able to learn about what went wrong, and they took the necessary steps to implement safer protocols for future space travels. Since 2011, all of NASA's space shuttle missions were completed, and NASA currently depends on Russia's Soyuz to travel to and from the International Space Station. Boeing and SpaceX are hopeful to be the next ones to carry the torch and bring people to space. So what does the future of astronomy hold? What are some of the mysteries of the universe that are yet to be solved? Where do we want to travel next? What are SpaceX and Boeing developing in space travel technology? What is the James Webb Telescope? And when are we planning to launch it? And what are some of the theories that explain the fate of the universe? Chapter 3 of the Evolution of Astronomy is coming right up. Now it's time to look at our accomplishments in the present, as well as what the future of astronomy holds for us. Thanks for joining us today on Feed My Curiosity. Don't forget, you could stay up to date with us by hitting the like and subscribe button. We have more videos coming up that we want to share with you. With NASA retiring their space shuttle program, it is now up to other companies to take the lead in bringing people to space. This is where Space Exploration Technologies Corporation, or SpaceX, comes in. SpaceX was founded in 2002 by entrepreneur Elon Musk. The company's goal was to revolutionize space travel technology and eventually be able to colonize planets. SpaceX's first major accomplishment was back in 2008, when its Falcon 1 became the first privately developed liquid fuel rocket to launch and orbit Earth. A year later, Falcon 1 Flight 5 successfully delivered a commercial satellite into Earth's orbit. SpaceX has been exploring a way to deploy reusable rockets, and this was demonstrated with their Falcon 9. In 2010, Falcon 9 completed 100% of its objectives on their first flight, and in 2014, the Falcon 9 completed its first stage landing into the Atlantic Ocean, and a year later, it completed its first land landing after successfully delivering 11 communication satellites into orbit. Perhaps Falcon 9's biggest accomplishment to date is being relaunched in 2017 for a delivery mission and landing again back to Earth. Falcon 9 has shown great progress in SpaceX's research in reusable rockets. One day, we're going to need rockets capable of delivering larger payloads and being able to travel farther, like Mars. This is where Falcon Heavy comes in. And in early 2018, it has already completed its first flight. It's not just SpaceX developing space travel technology too. Boeing is also pretty ambitious on bringing people to Mars. Among its products in development is the CST-100 Starliner, designed to carry up to 7 passengers or passengers and cargo, and can be reused up to 10 times. The CST-100 Starliner also adds comfort to space travelers by providing wireless internet and tablet technology. It's not up to us to say who's leading leading the world in the development of space travel technology. The most important thing right now is that we have people with the ambition of taking us beyond the stars. So what does the future of space travel and exploration hold in store for us? One planet we're hoping to visit one day is Mars. We already have rovers like Curiosity and Opportunity roaming the red planet, and NASA hopes to send the first Earthlings there by the 2030s. Aspiring space travelers can already experience it with the Mars 2030 virtual reality simulator. A couple other destinations we're hoping to visit are Titan and Europa. What makes these moons special is that they are believed to have oceans. Europa, the icy moon that orbits Jupiter, is still geologically active, and beneath its surface lies the possibility of a liquid ocean. Could there be microorganisms or fish swimming under there? Or maybe an underwater colony inhabited by intelligent life? Who knows? NASA really wants to explore this moon because who knows what we'll find there. And Titan, which is the largest moon that orbits Saturn, seems to be more like a planet. It's bigger than Mercury and Pluto, and it's the only moon in the solar system to have a significant atmosphere, which contains nitrogen, like the Earth's atmosphere, as well as methane, hydrogen, and maybe argon. Organic molecules are also present in the atmosphere. We can't see what exists on the surface, but it's believed that ethane methane has formed an ocean. Infrared images of Titan reveal some interesting surface features, with one bright spot as big as 2,500 miles wide. There's really only one way to find out what's really on that thing, right? Meanwhile, the International Space Station is approaching its 20th year in orbit since its launch in 1998, and people seem to be motivated to keep it going. The ISS is expected to be active until 2024, although a House member has introduced a legislation that would extend its operations to 2030. Even then, there seems to be a gray area about what will happen with the ISS after that point. But we're sure that with improving space travel technology, it will still have its use down the road. And what about space telescopes? We already have the Hubble, which is capable of capturing images of the universe up to 15 billion light years away, proven by the Hubble Deep Field. The James Webb Telescope, or the JWST, is capable of seeing much farther than that. The Infrared Telescope will be able to see baby galaxies and get us a better understanding of the universe's origin as it peaks closer to the Big Bang event. Remember, because it takes time for light to reach us, the farther we look into the universe, the farther we are looking back in time. Looking at the sun is basically looking at the sun as it was 8 minutes ago. But please protect your eyes and don't do that. The JWST is facing some issues right now, but we're hoping the telescope will be launched into space by late March 2021. We also have some ongoing NASA probe missions. Since 1977, Voyager 1 and 2 have explored Jupiter, Saturn, Uranus, and Neptune, as well as their moons, and are now investigating interstellar space. As of August 2017, Voyager 1 is about 20.8 billion kilometers away from the Sun, while Voyager 2 is about 17.2 billion kilometers away. There is also a chance that Voyager could be intercepted by extraterrestrials, which is why NASA has prepared them with the Golden Record. The Golden Record is a phonograph record that shows our alien friends how to first of all use the record, and if they can access the record, they'll be able to hear everything us Earthlings have to offer about our planet, including nature sounds, music, and spoken greetings in 55 different languages. And who could forget New Horizons? It's thanks to our little buddy that we have high-resolution photos of Pluto that we can now use in elementary school textbooks. And New Horizons isn't stopping there. It's now set out to explore the deep regions of the Kuiper Belt, filled with icy objects that have said to be the remnants of the solar system back when it was forming. With all the innovations made to study the universe, there's also some unsolved mysteries we're still trying to figure out, like dark matter. Recall what we talked about in the first chapter, when black holes were recently ruled out as dark matter. What we know about dark matter is out there's a string that's pulling and tugging stars to make them move the way they are. We just don't know what this string is yet. There's also a question of, are we alone in the universe, or do we have extraterrestrial neighbors? We don't know the answer to this, but it hasn't stopped us from trying to contact them. Back in 1974, we sent the Arecibo message to the globular star cluster M13, which is about 25,000 light years away. This is how long it would take for the message to be received, and if it does get received, it will take another 25,000 years or so to receive the reply. Even then, however, in 25,000 years, the destination may not even be there. The Arecibo message consists of a picture containing the Arecibo telescope, the solar system, DNA, a human, and biochemicals. Recently, in 2017, a message was sent to GJ273, also known as Newton's star, which is about 12 light years away. The red dwarf includes the planet GJ273b, which is capable of supporting life. This message includes science and math, as well as music. The star is pretty close to us, so it shouldn't take very long for our message to reach its destination, and then get a reply come to us. We're in for an exciting future. Another mystery that is unsolved is just how big the universe is. We don't really know for sure. There's this thing called the observable universe, and when we measure it with us right in the middle, its radius is roughly 13.8 billion light years away, and that's only the observable universe. We don't know what exists past that. And finally, since we have theories of how the universe started, we also have theories of the fate of the universe. We know that the universe is expanding due to the red shift. As demonstrated by the Doppler effect, light observed in the universe is moving away from us towards the red spectrum. So if the universe did begin with the Big Bang, what happens next? If things continue to move away, will this result in the Big Rip? If the universe stops expanding and everything begins to move back and collapse on itself, will this result in the Big Crunch? What if there's no more thermodynamic free energy and the universe goes into a big freeze? Okay, we didn't mean to depress you at the end of the video, but for the sake of optimism, we could say that another possibility is that everything will keep expanding like it is, and everything will keep working for eternity. With all these theories about the fate of the universe, there's really no knowing for sure. And if we are to understand how the universe works, how it came to be, and how it will finish, it all starts with the understanding of whatever the heck this dark matter is. Astronomy has really come a long way since our Paleolithic ancestors started looking up at the night sky. The more we are able to discover and accomplish, the more that science fiction becomes a reality. Who knows what comes next, but we're certainly in for an exciting future. If you know of any other goals that people hope to accomplish in astronomy, or if you have any other comments, go ahead and post them below. And don't forget to hit that like and subscribe button. Thanks for watching, and we'll see you next time on Feed My Curiosity.